is right there. I need to figure out what the size is, and I need to figure out that angle right there. So how would I find the hypotenuse? So if I label this something cover like C squared is equal to 3 squared plus 6 squared. So that's this. So C would be the square root of 45.
6.7.
Say 36, 9, 45, yeah. Now you have calculators, putting it into decimal form is simple enough. But square root of 45 is a valid answer. Don't let the math people tell you you have to reduce it into, I guess, 3 root 5. But now so I have the hypotenuse now. I need to figure out what that angle is. Well, I got my handy dandy trig. I got my 3 rules over there. I now know the hypotenuse, but what's given to me are the 2 shorter sides. So tangent makes the most sense. If you use the other ones, I'm not taking off for it. It's typically recommended the less rounding involved, the better. And since 3 and 6 are not rounded, as far as we know, we can use those. So if this is my angle here, theta, the tangent of theta is the length of the opposite side of the hypotenuse. And so on your calculator, if you need to solve that, we need theta by itself, but it's got this tangent hanging on, so we have to somehow rip tangent away. Well, you do that with an inverse trig function. Opposite of tangent is the arctangent. So the arctangent, do it to one side, you gotta do it to the other, because that's what the math people keep telling us. Arctangent of tangent is just, they cancel each other out, and I'm left with theta is equal to the arctangent of 2. I'm guessing none of you have calculators which have arctangent on it. Where it says arctangent?
Yeah.
It is? Okay. You will also, on my calculator, it's listed as atan, and on the TI 80 whatevers, it is listed as tan with a little -1 up there, 2. In class, I will tend to write it this way. I'm really not a fan of this notation, but I understand what they're saying. And so on your calculator, I would type 2 second function tan, which is the arctangent. And on yours, I guess you would write tan -1 parenthesis 2 close parenthesis enter. Okay. And what do you get?
63.4.
63.4 degrees 3. I think someone just said it.
Degrees?
Yeah. And so in polar form, this is square root of 45 meters. The meters is not under the radical. Just be careful about that. Comma 63.43 degrees. Questions to hear? In module 0, I think it's the second, I think the first one is chapter 1, and the second one is review or math things that are helpful. I forgot the way I've labeled it. I've got videos where I go through this.
In my seminar folder. I hope we get time.
Okay. Questions before we connect it to chapter 2?
Do you want us, when we're providing our answer, like, are we gonna have a label for the vector that you want us to find, that you want us to include, like vector A equals?
Typically, in this, I guess in this particular problem, I did not give it a name. But typically I do. All right. talk about vectors and scalars. At this point, you people are experts on vectors. Scalars, I'm assuming you're experts on scalars too. There are certain vocabulary words. That's right. We're about to do everybody's favorite part of any chapter, vocabulary. There's certain words that immediately, as soon as you see that word, you should be thinking, vector quantity. There's going to be a magnitude and a direction. There's certain other words that automatically are scalar. You think, I don't care about, there is no direction involved. And there is one particular word which actually could go either way. So, the vector words. Not chapter 2, this is chapter 4, but force is a vector. Typically, F. And I put a little vector symbol over it. Displacement. This is chapter 2. Displacement is a vector term. Probably should have done another one first. I'll come back to the symbol in just a moment. Position is a vector term. The symbol for position, I tend to use X, Y, Z, R, S. Those are the most common terms, common symbols used for position.
But it could be.
Yeah, I would recommend staying away from some of the other, don't use V because they were using that for something else. It would get really confusing. But if you're using something other than those, you probably should define it somewhere. Years ago, I had a student who had, for the greater than, less than symbol, he wrote it down backwards. For some reason in his head, the less than, the traditional less than symbol to him meant greater than. Instead of changing the way he does it, at the beginning of his quizzes and tests, he defined it. He defined the symbol his own way, so he wouldn't have to switch. All right. Displacement is just the change in position. So we represent change because we're not going to write change. Of course not. That would be silly. We have a symbol for it. What's the symbol for change? Delta. Delta X. Delta Y. It's delta in front of whatever letter you're using for position. X, Y, and Z come from the traditional math X, Y, Z axes. Are generally used when you're talking about radial directions. There's a central point, and how far are you away from the central point. And S comes from the Latin stibium. All right, velocity. Velocity is a vector. The symbol is a V, with a vector symbol over it. Acceleration, A, with a vector symbol over it. Now the first four are written up here. Those words immediately, that's a vector. Acceleration is the exception. The acceleration could be a vector or a scalar. Really been nice if they come up with a different word, but they didn't. On a problem, how do you know which one you're solving for? I've gotten much better about this. I will put, if I'm asking for acceleration, I'll put the vector symbol over it, or I'll say vector acceleration, or I'll give the symbol of which A it is, whether it's a vector or a scalar. Textbooks, you have to guess from context. All right, scalar analogs. There is a scalar term, but I just want to throw this in. This is, again, chapter 4, mass, typically M. Mass is a scalar. Just bring it up now because trying to see if I mention it early enough whether people will not make a common mistake of thinking mass and weight are the same thing. They are not. And I don't care what you've done in biology or chemistry, mass and weight are not the same thing in physics. We need to distinguish. All right, distance is a scalar term. And the symbol x, y, basically it's, it's any one of these without the vector symbol. So delta x, no vector symbol, delta y, etc. Speed is a scalar term. The symbol is just a v. It is not s. V without the vector symbol. And then acceleration a without the vector symbol. I think it's the third lab where you need to be really careful about that. I do explicitly write acceleration a vector or acceleration just a terminal a. Questions to hear? All right, I've done the excitement of the vocabulary words, but what I haven't done is actually define them other than some hint at displacement. So let's actually get into definitions. And while I'm thinking about it and erasing, if you have not taken the course entry assignment, please do. It just makes life simpler for the meeting counters. And in turn, simpler for me and my boss. Sorry, I was gonna go off on a tangent, but enough. Position. Where an object is with respect to the origin. Displacement. Displacement. There are basically two definitions. Where an object is with respect to the starting point, or change in displacement. Is it trying to read my handwriting, Margaret, or trying to figure out what this actually means? Or both?
I was just trying to read it. Where an object with respect to the
Starting point.
Okay, thank you.
Eventually I'll get this stuff posted under chapter 2, and so you could watch it again and bring your friends around, have a big viewing party of this is what I did. They'll be so sad for you. All right, so let's actually talk about how this is different. So let's say that I've got some coordinate grid right here, and I am here. You can think of this as longitude and latitude if you want to, but I have some grid, an origin that's established some particular place, and this is my starting point right here, which I'll abbreviate as just SP for starting point. My initial position is a vector from based on the origin to where that is. So this is my initial position. So I'll just write x with a subscript I, x with a vector symbol, and then a subscript I for initial. Sometimes I'll put a little 0 for when time is 0, or I'll put an O, which looks a lot like my zeros, for originally. I then move to a new place. I'm here and I move to here. So I'm now at this spot. That is my final position, again, relative to my origin right there. So this would be x subscript f for final position. But my displacement is the difference between these two, or where I am relative to where I started. So this vector right here is my displacement. Yes,
So the starting point is not where the graph meets.
correct.
Okay. In this scenario anyways.
Good, yes, yes. Now, there is some flexibility, you can make the origin anywhere unless it's given to you, and I will tell you, the last problem in the first test, I will tell you where the origin is. And unless it's given to you, the origin is wherever you want it to be. And so,
What's the XF?
final position,
Okay.
using the X for position and then F for final.
Okay.
I forgot what I was going to say, so what I was going to say before that. All right, so I was born in Florida. And then I moved up to Richmond, then to Charlotte, then to Asheville, then to Columbia, South Carolina, then to Charlotte, then to Winston-Salem.
Did you actually?
Pardon?
Did you actually?
Yeah, that's basically my life journey. Right?
Where in Florida are you from?
Boynton Beach. Heard of it? No?
I
From there
used
as
to
well?
live in Winter Park.
Ah, I had a roommate from Winter Park. Actually, two roommates from Winter Park.
That's cool.
All right, so the distance I've traveled, I'm gonna make up numbers here because I don't know exactly the distances here, but let's say that's 500 miles. And then down here, we'll just say 200 miles. And then 50 miles, I know that's not right, but we'll pretend 70 miles. And then 100 miles. That is really cluttered.
Quite.
Hopefully you got the spirit of what's going on there. So the distance I traveled, so I use the word distance, that's a scalar. I don't care about direction, all I care about is how far have I gone, so it's just 500 plus 200 plus 50 plus 70 plus 100. Doing the fancy math here. 4, 9. That is the distance traveled. That is over the course of 60 years. So I could find my speed by dividing that by 60. That would be my average speed. Obviously, I simplified my life there. I have gone on vacation. I have gone to other cities besides those. Now, my displacement.
It's supposed to be 920. Yeah.
Pardon?
It's supposed to be 920.
920?
Yeah. 5 plus 7.
Oh, I had that 2 in a row spot in my head. Thank you. 920.
I was assuming I was worse at math than I actually was.
All right, let me give you a hint here. When you're dealing with physics, assume everyone else is an idiot. If they disagree with you, you have to develop the look of, that, I can't believe I have to deal with you. You are
The
beneath me.
face
So-
that you make like every 5 seconds.
So this is what you do. Thanksgiving is happens during the semester. It's a good chance to practice on your family. If they say anything you disagree with, just give them the look. Go. Let me talk to you like you are 3 years old. And then tell me how it goes. All right, no, that was my mistake. We'll all make mistakes here. Sorry, I didn't mean to set that expectation. I will make mistakes in here, the rest of you will be perfect. All right, my displacement for my life. I started here and I ended up there. I don't care about anything else that happened in between. All I care about is from here to here. So let's go for that stunning effects here. Ooh. That is my displacement. And just to simplify matters here, so that's 5. So basically I've gone, we'll just say 400 miles north and 20 miles west, or 400 find these things, shorthand notation here. Not how you erase on this board. 400 miles north minus 20 miles east. So that would be my displacement. My final position, well, it depends on where the origin is. I could make it, that brings me back to what I was gonna say. We're done at 20 or 15? 20. All right. When we pick the origin, typically, globally, we do have zero longitude, zero latitude, somewhere off the coast of Africa, I think, or West Africa, somewhere in there. But it doesn't have to be. I could, if I said the origin was right there where I was born, then not only is that my displacement, that's my position. If I said that the origin was here where I am right now, then that's my displacement, but my position is 0. So what direction, if you have a 0, what direction do you pick? What direction would you pick if you had a magnitude of 0 in your vector? It depends on what you mean by that.
Can you repeat the question?
If I have a vector that has a magnitude of 0, what direction would you pick?
Horizontally?
Pardon?
Horizontally?
Okay, why? Just feels right?
Felt right, because you always draw the eye first, so I was like.